3.5, graph linear relations by hand. So a linear relation can be graphed by plotting a series of points or by plotting the y-intercept first, and this would be like our reference point, and then applying the slope to locate other points. Some situations can be represented by linear relations. If there is a constant rate of change between two variables, this is the slope. The initial value is the y-intercept. So let's go ahead and look at how we actually graph these. Example 1, for each line, identify the slope and the y-intercept, then use them to graph the line. So for A, we have y equals 2x minus 3. So we have the slope is 2 and the y-intercept is negative 3. So we first have to plot the y-intercept, which is negative 3. That's our reference point. Okay, that's where we start. And then what we have to do is we have to apply the slope to this point here and graph just a couple more points until we can connect them with the line. So when I think of slope, I think of rise over run. In this case, it's 2 over 1. So starting at this point, we go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. You just plot a couple of the points just so that when we put the line through it, it's quite accurate. Okay, so put the line through these points, put arrows on both ends, and we label the graph. Y equals 2x minus 3. Now for B, we have y equals negative 3x plus 5. Okay, we have the slope here, which is negative 3 or negative 3 over 1. Okay, remember the rise over the run we need. And then we have the y-intercept of 5. So first plot the y-intercept because this will be our reference point of like where we start. Then apply negative 3 over 1. So we're going to go down 3 over 1. Right, down 3 over 1, down 3 over 1, down 3, 1, 2, 3 over 1. Okay, and I can connect these with a line, put arrows on both ends, and label our line. Y equals negative 3x plus 5. Okay, same thing, example 2, it says graph each line. So this time it doesn't actually tell you to do the legwork behind everything, but it's always good if we do because then our answer is organized. So we're going to state the slope, which is 3 over 4, which is the rise over the run. We're also going to state the y-intercept, which is negative 1. So negative 1's here, and we're going to go 1, 2, 3, up 3, 1, 2, 3, 4 over 4. 2, 3, up 3, 1, 2, 3, 4 over 4. Okay, I'm going to also go down 3, 1, 2, 3, and left 4. Just keep with the pattern the way that the line is going. Okay, so we connect these points with a line, of course using our ruler, put arrows on both ends, and label a line. Okay, for B, our slope is negative 1 over 2, which is going to be the rise over the run, and our B is 4. So first graph the 4, we need a reference point, we need a starting point, okay, and then apply the slope. So down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Okay, and that's enough points to make this nice and straight with our ruler. Okay, put arrows on both ends and then label your line. Example 3, this is going to be a word problem, doing the same thing, graphing an equation. Okay, so example 3, a pizza costs $12 plus $1.75 per topping. Graph the linear relation that models the cost up to 4 toppings. So we're going to fill in 0, 1, 2, 3, 4. Now the starting cost is $12, and then you add $1.75, so you get $13.75. Then we add $1.75, and I get $15.50. And then we add $1.75, and I get $17.25. And we add $1.75, and I get $19. Okay, so A asks us to graph the linear relation that models this. So let's go ahead and graph these points, okay? So between 10 and 20, 10, 12, 14, 16. This would be 5, right? So this would be 15. So we would start at about 12 here, 1 comma 13.75, 2 comma 15.5, 3 comma 17.25, 4 comma 19. Okay, so we can go ahead and draw that with a line. Okay, B, determine the cost of a pizza with 2 toppings. So we did right here, we patterned, right? Cost is $15.50, and we showed that on the graph, so that's good. Now determine the number of toppings of a pizza with a cost of $22.50. So here's the thing, $22.50, so this here would be 25. $22.50 is going to be around here. Okay, but let's actually take a look at the equation. So we left off at 419, right? So let's just pattern 5, 6, and then we'll take 19 and we'll add 175 to it. So we get 2075. Add another 175. And then we get 2250. So we get 6 toppings. Okay, if we went here and we went up 6, well, it would intersect 2250, so that's good. This will be 6 comma 2250. Okay, now let's write an equation relating C, which is the cost in dollars, to N, the number of toppings. So no matter what, we're going to have to pay $12 for the pizza, and then we're going to pay $175 per topping. Okay, so this is going to be the equation. If you wanted it in y equals mx plus b form, we can simply just change the position of the 12, and the 1 decimal is 75n. Okay, now E and F ask us to verify B and C, but actually using the equation. So I'm going to do E up here. Use the equation to verify the 2 toppings. So simply, I'm going to go cost equals 1.75, substitute the 2 in, plus 12. Okay, so I get 350. Yeah, 350 plus 12, which is 1550. So that's verified. Okay, now use the equation to verify the number of toppings on a pizza that costs $22.50. So this time, I'm going to substitute the $22.50 in, but for the cost, 1.75n plus 12. Now, subtract 12 from both sides. We are left with 1050 equals 175n. And I'm going to go ahead and divide both sides by 175. And I'm going to just triple check. Yep. And I get n equals 6. So we just verified F using the equation.